Hello from Vero Beach and welcome to Navigation Made Easy, one of our many training videos. In this video, Navigation Made Easy, we will help you learn how to glance at a chart and look out the window and see what's ahead of you and fully understand navigation procedures. So if you're ready, let's get started. Hi, I'm Captain Chris. My wife and I are cruising coaches and look forward to helping you start your new adventure. Navigation Made Easy is designed to help you understand the aids to navigation and trip planning. Trip planning will be easier when you've got charts, waterway guides, anchoring guides like this. You can see on this chart, the winding ocean inlet has a lot of possible anchorages, but the anchor guide will help you decide which location will be better depending on the weather, the wind, and the tidal currents. Other tools will be good eyeglasses. A lot of people forget their eyeglasses at home, so bring the eyeglasses aboard the boat with you. And of course, a magnifying glass. A lot of the print on these charts is very small, so a magnifying glass is very much appreciated. Polarized sunglasses. Got to have the polarized sunglasses to cut down on the glare both from the sun and the sun reflecting off the water. Remember, this is pleasure boating. Let's have some fun. So now let's start looking at charts. I say looking, not studying, but just looking. Let's look at the charts. You can see we've got three basic colors, maybe four. So the white water is the deeper water. This chart that we're looking at is the ocean between Florida on the left and the Bahamas on the right. So you can imagine that the ocean is very deep, and that is white colored water on the chart. Blue is more shallow water. You can see as we approach the landmass of the Florida Peninsula, the water is blue on the chart, so therefore it's more shallow. And on the right, you can look and see the Little Bahama Bank. That's blue. That's very shallow also. And then, of course, the mustard or mud, that's land. And if you get a closer detailed chart, you can see khaki green, which is sometimes land, sometimes above the water, or sometimes below the water, depending on high tide and low tide. And that means it's a sandbar. Be aware, you don't want to run aground. Let's look at this large chart kit, Map Tech chart kit. And I say large. In one way, large is good because the screen or the page is very large. You can actually see. You can look north, south, east, west and appreciate where you are. And some people may say it's a little bit too big for their boat, but a lot of boats, even as far back as the 1970s, are built with chart drawers to put these into a chart drawer and then pull them out and lay them up on top of a chart table. But the fantastic thing about this chart kit is, in this case, it's the Florida East Coast. It will go from the Georgia state line all the way down to Key West, and you just keep on flipping the pages. Page 1, page 2, page 3, page 4. Each page has a key like A, B, C, D, and it will show you where to start on the next page so that everything, it's not actually seamless, it has a seam, but it's smooth operating. It's easy to figure out where to go next. In the back of the book, they have these pages. There's 3 pages like this, and it will explain all of the codes, all of the symbols, all of the acronyms that are on the chart, like sandy bottom, muddy bottom, sticky bottom, overhead power cable, underwater power cable. All of these things are explained in the back of the book. So that way, if you see something you don't understand, flip to the last page and you can find the code or the icon or the acronym to figure out what it is. So let's go back and look at this chart again. This is the Florida East Coast, and you can see the Bahamas on the right, the ocean in the middle. And let's look at that yellow arrow pointing to page 41. So this is showing you how well this chart kit is put together. So page 41 is the inlet into Fort Pierce. We live in Vero Beach, which is 15 miles north of Fort Pierce. But if you're in the ocean and you want to bring your boat north to the Vero Beach City Marina, you will have to come into the Fort Pierce Inlet and then follow the Intracoastal Waterway up to Vero Beach. Let's talk a little bit about communications. We'll get back to the charts in a few minutes. Communication is key between the navigator and the helmsman. So the helmsman is actually driving the boat, following a course that you have both agreed on. So you're following the channels, the red and the green markers, etc. And if the navigator sees a boat coming across your bow, the navigator may say something like, do you see that boat at 2 o'clock? The bow is 12 o'clock. To the right is 1 o'clock. To the right is 2 o'clock. And a beam of the boat would be 3 o'clock. So let's say there's a 20-foot outboard crossing our bow right to left at the 2 o'clock position. And the navigator confirms all that. The helmsman says, yes, I see that. Just monitor the situation. You may not have to take evasive action, but just watch and see where that boat goes so nothing exciting will happen. So we talked about communicating. So communicate like you're on the telephone. So you heard me say, do you see that outboard boat? So I described it as an outboard boat, which is probably 20 or 30 feet. It's at 2 o'clock, which is to my right-hand side, and it's crossing my bow. So that would be what we call telephone discussion. So what I said, you can imagine in your mind, instead of me, the navigator, telling the helmsman, look over there, and as the helmsman, you're going to say, over there where? You can't say over here. Just say 2 o'clock, crossing your bow, outboard boat. It's very, very easy to speak like that. You just have to think to speak like you're on the telephone. The key thing with the helmsman is to acknowledge that they heard and understood what the navigator told them. So let's look out the window. So these are some of the things that you'll see. On the left, I'll see a green square with a number 1. Of course, it's got a bird on top. And then I see the white sign below it, and you can see 30 miles per hour or slow speed. So those are speed limit restrictions on the waterway, maybe because of manatee zones, or maybe because there's a back down boat ramp or marina nearby. In the middle screen, we've got the buoy, the floating buoy, number 12. You'll notice it's red, and you'll notice that there's a light on top of it. And then to the right, we've got all these boats going all kinds of crazy places with pilings all over the place. So this is where your navigator is truly helpful. You're driving the boat, you're looking out for other boats for collision possibilities, and your navigator says, go here, go there, go somewhere else, like you're speaking on the telephone. So you may want to steer dead ahead and follow that large sport fisherman, because you know, looking at the boat, he's got to have at least a 5-foot draft, so you know he's in deep water. Now we're looking at a marker. This is typical of any type of a marker, aid to navigation, ATON, and this marker is plywood on a piling driven down into the seafloor. So now we need to learn the difference between the red triangular markers and the green square markers. So here is an easy clue. If you think of rent, R-E-N-T, that will mean it's a red marker. It has an even number, 2, 4, 6, 8, 40, 42, 44, whatever, all even numbers, and they're on triangles. So anytime that you're looking on the chart and you see a number 2, you know it's going to be a red marker, you know it's going to be a triangle. So this is the easy way to remember the ATON, red even number triangle. And now we've got the green marker, square, odd number green. You can see the green plywood. In fact, this has got a light on it with the bird standing on top of the light. So just like the RENT, we now have an SONG, song, square, odd numbered green. Easy to remember. Anytime somebody calls out an odd number, 15 or 27 or whatever, you're looking for a green square marker. Moving into the buoys. So we've got a floating buoy, buoyant buoy, floating buoy, and they still follow the same codes as RENT or SONG. This one obviously is red, has a triangular top on it, and is an even number 12. As a bonus, there's a light on top of the 12. Now we've got the other colored buoy, green. So think of SONG, square, odd numbered green. So it's really not square, but it does have a flat top, so that fits with the square concept. And it has an odd number, 81, and it is green. In fact, this has got a Charlie, 81 Charlie. We'll talk about that in just a couple of minutes. So the buoys or day markers or day beacons, all of the ATONs, aids to navigation, all carry the sequential numbering system. So all of the greens are odds, all of the reds are even numbers, and they're in sequential numbering, something like a 1, 2, 3, 4, 5, 6, 7, 8, so you can tell how far you're progressing in the marker system. Now we've got this square odd numbered green. Think of it as a can, and some people even think of it as Jolly Green Giant comes in a can. Get it? But it's a 17 odd number, square, and green. But look at the alpha, 17 alpha. This is because there's an extra buoy, in this case it is a floating buoy, in the system. Maybe a storm came through and the channel shifted a little bit. A sandbar encroached into the deep channel, so the Coast Guard had to reroute the boating traffic around the end of the sandbar, so they came up with the ABC suffix system. This only has one additional buoy, 17A. Now we're in a different part of the waterway, and you can see we've got a day beacon, a day board, day marker with a light on top, and this red even number triangle is 48 Bravo. So looking on the left, you can see there was a 48, and there's a 48 Alpha, and a 48 Bravo, and then a 50. So this channel's moved so much that the Coast Guard had to put in 2 additional ATONs to help guide the marine traffic around the shifting sandbar, 48 Bravo in this case. Wow, here we go. We've got a Charlie. So looking on the left again, 81, 81 Alpha, 81 Bravo, 81 Charlie, and then 83. So this must have been a pretty serious sandbar shift, maybe a hurricane, maybe a month ago, maybe 3 months ago, and the Coast Guard had to come reroute the channel around the shallow areas that had shifted. So be thankful that they're out there, they're correcting the channel system. But if you see anything with an Alpha, Bravo, Charlie, or even as high as Golf, the Coast Guard has rerouted the channel, and it may not show up on your GPS or your laptop or your paper charts. So be aware that these are additional buoys, and they're designed to route you around the sandy, shallow areas. And now we come upon WR. So if this is a red, it's got a pointy top like a triangle. It's got a light on top of that, and it has the letter WR, which is easy to figure out. That means wreck. Looking over to the left, you can see some sort of a metal obstruction above the water. We don't know how big the rest of the obstruction is under the water, so stay clear. This is obviously a wreck buoy. So now we're looking at the channel marking system. We've got all of the day markers, the day beacons, and the floating buoys, and they're running up and down, following the channel. And if there's a fork in the road, so to speak, how do you know which one is the intracoastal waterway and which one is just a regular channel? The answer is very simple. Look for this. The yellow decal. So it's difficult to see on this red marker, but look at the top of the triangle. You can see that yellow decal at the top of the triangle. Again, rent, R-E-N-T, red even numbered triangle, 36. So you can see the yellow decal, and this says I am an intracoastal waterway marker. On the top of that, you can see that galvanized metal piece. That's actually a radar reflector. So even though this does not have a light on it, no battery system, no solar charging system, it has a radar reflector. So your radar can pick this up in the rain, in the fog, and at night. Now we've got an illuminated, flashing day beacon. You can see the flashing light up on top. Not flashing now, it's daytime. But you can see the solar panel on the left and then the battery there to keep it flashing all night long. And look again, you can see that yellow decal, intracoastal waterway. Now we've got something that is important to understand. When you're driving your car and you approach a stop sign, the stop sign is perpendicular to the road that you're driving on, and as if there's an imaginary line across the road for you to stop. So when you're driving down a channel, the day markers that are on pilings and the day beacons that are on pilings, they also will be perpendicular to your direction of travel. Looking at the left-hand photograph, if you're approaching a day beacon or a day marker like this, you're either coming from an anchorage outside of the channel, moving into the channel, or something worse, you just might be out of the channel, and hold on tight because you may run aground pretty soon. Keep in mind that your ATONs, aid to navigations, your channel markers are perpendicular to your direction of travel. Hopefully that'll help keep you in deep water. Same thing here. We've got the bird on top of the green number 1, but we're traveling and it's perpendicular to our direction of travel. I do want to point out the white sign at the bottom, which is a speed restriction sign or speed limit sign. Looking at the left, it's 30 miles per hour in the intracoastal waterway, and on the right, it's slow speed intracoastal waterway included. This is basically a manatee zone. You can see that at the top of the sign. So in the winter months, the manatees are all over Florida, and you have to go slow to avoid hitting them. In the summertime, they migrate out to many different areas where the water's then warmer up north in Georgia and the Carolinas, so we do not enforce a speed limit restriction in the summertime. Now we've got the question. Red is on your right. When is the red on your right? The answer is simple. When the numbers are rising. So if the numbers are rising, the red should be on your right. Red, right, rising. For example, 2468, they're on your right. It's that simple. So red is on your right when the numbers are rising. 1, 2, 3, 4, 5, 6, 7, 8. The reds are on your right, technically 2, 4, 6, 8. But that also means that the greens are on your left. So it's easy to figure out where the channel is. So if the reds are on the right when rising, you can know exactly where to put your boat, and then of course you'll be in the deeper water. Now what do we expect from your chart? Hopefully an updated chart, GPS on the dashboard of the boat, maybe even a laptop computer with a charting program, and a paper chart. So you've got all of these different features and options for comparison. Hopefully they're up to date and uncluttered, not too much information. Too much information is distracting. and we like to have something for the captain or the helmsman and something different for the navigator, so that way your navigator can be looking ahead without distracting the helmsman. So if you've got two sets of charting information, or even if you just handwrite a trip plan, that would all be helpful to keep you in the deeper water and on course. This is a photograph of a paper chart, Lake Worth, which is above Palm Beach, Florida. A few things that I want to point out. First of all, look at the white area on top. That's in the ocean. Deep water is white. Then look between the beach, the brown mustard mud, or the land part. Look between the beach and the middle of the chart. You see all of that blue where it says Lake Worth. Look a little bit closer and you can see that blue is 2 feet deep, 3 feet deep, or 2 feet shallow, 3 feet shallow. And you can look over to the left where I've drawn a little anchor with a little yellow highlighter. That's where we've anchored in the past. Notice again that's in the white area. It's 11 feet and 14 feet deep. So this is looking at a chart at a glance without studying it. So now I've got an arrow pointing our direction of travel, which is left to right, or technically it's southerly. So we're traveling along this man-made canal, and we'll veer a little bit to the left. We'll go out into Lake Worth and then veer a little bit to the right. Let's follow along and see where we go. You can see there that we've got a bridge. We'll deal with that in a couple of minutes. And then we're heading out into the open water of Lake Worth. Hopefully it's not too windy or rough. And as we've come out into Lake Worth, we've turned to the right and we're headed down the channel, again southerly. So you can see where they've actually drawn like lines on the side of a road. That means that the channel is very narrow, so stay in the deep water. Looking at this, you can see the arrows pointing to a magenta line, pretty much vertical. It says STM, that's statute mile, and it's 10:15. So this is one way of measuring your travel, or also knowing how far you are from Norfolk, Virginia. The Intracoastal Waterway begins in Norfolk, Virginia, technically Portsmouth, Virginia. And the paper charts are marked off in 5-mile increments like this. So this means that we're 1,015 miles from Norfolk, Virginia, as the Intracoastal Waterway zigzags back and forth up and down the coastline. So this is easy for you if you want to figure out 50-mile travel days, 60-mile, 75 or 100-mile travel days. You can look on the charts and see where these statute mile markers are drawn on the paper chart. Looking at this arrow, you can see that we're still in the very narrow channel because they've drawn the lines. This is extremely shallow water, and if you get just a few feet out of the channel, you might be shining up the blades on your propeller. Shallow water. Now this marker is showing R30. That means red 30. You can see the red triangle a little bit to the left of the R, and the 30 is in quotes. Quotes is the number of the ATON. In this case, it's 30. Look a little bit to the left of 30. You can see 7 in the white deeper water, and further to the left you can see 2 in the blue area, the more shallow part. So those are water depths, and the 30 in quotes is the ATON number, or the channel marker number if you want to say that. Here we've zoomed in. It's a lot easier to see. See the 30 with the quotes, the 7 in the white, the 2 in the blue, and then the red triangle to the left of the R. And you can see a little bit more detail because we've zoomed in. In your case, you might be using the zoom feature on your GPS chart plotter, or you might be using a magnifying glass on a paper chart. You can see we're starting to head south, left to right. We're leaving red number 30, 30 with the quotation marks, and we're headed to the right towards flashing red, 2.5 seconds, 16 feet tall, in quotation, 30 alpha. You can see the exclamation point. Just above that, you can see the square green 31, also in quotation marks. So looking a little bit closer here, inside the circle, you can see the FLR. That's not Florida. That's flashing red. Again, 16 feet tall, 30 alpha. To the right of that, you can see the exclamation point, which means it is a day beacon or flashing light. A little bit to the right of that, you can see 4 feet shallow water. Just above that, the green square with 31, also in quotation marks. As we leave that, we're going a little bit more to the right, to the south. You can see this arrow is pointing to an intersecting channel. This is the channel going into Lake Park City Marina. So again, there is a flashing day beacon. You can see the exclamation point saying, I am a flashing aid to navigation. Little bit more to the right, after we've passed Lake Park, you can see that we have C insert A, page 37. This is where we talk about the chart kit having page numbers, so you can actually turn the page to get a whole lot more detailed information about that. In fact, this arrow is pointing to a fixed bridge, horizontal clearance 90 feet wide, vertical clearance 65 feet tall. Looking again, this is the insert A that it asked us to turn to. Looking at the yellow arrow again, we're looking at the same bridge, but looking a little bit more to the right, you can see the Peanut Island. This is in Riviera Beach area. Palm Beach Island is on the top right. Singer Island is on the top left. Now, this is an interesting point that people don't think about. All strings of ATONs, buoys, or channel markers have a beginning and an ending. They generally begin and end at a major intersection of an inlet. In this case, this is the Lake Worth Inlet. Some people may call it the Palm Beach Inlet. Look at the arrow on the left. It says end of channel numbers, and you can see that's green 43. So that is the last marker, or the last ATON headed south in northern Lake Worth. And then as we go across the turning basin is where the ships turn around. Notice it's white, very deep water, over 35 feet deep. And you'll see the arrow on the right where it says start new numbers. So that's starting with an R2. 2 is in quotes, although it's in the blue section, which makes it deep or shallow. The blue section is actually shallow water, but the 2 is not the water depth, it's actually the number of the ATON, red number 2. Here you can see a little bit better. We've got the circle on the left with the green 43 in quotes. The circle on the right is the red number 2 in quotes, although it's over the blue, the shallow area. And just above that, to the left a little bit, you can see an exclamation point. And the circle's kind of obscuring it a little bit, but it's a quick flash green, 12 feet, 3-mile visibility, number 1. So if you want to look at this as the beginning of this new channel, number 1 green is to the left as we're headed in a southerly direction, and red number 2 is to the right. Keep in mind, red right rising. So they'll be on the right-hand side as we're headed south, or in the case of this photograph, as we're headed to the right side of the screen. Again, the arrows are showing the same information, and we're continuing to the right. We're continuing south. Look up at the top above the word Palm Beach. You can see the north arrow in the ocean. So that means north is to our screen left, south is to our screen right. Another thing to think about, the intracoastal waterway is actually crossing or intersecting with the shipping channel, where the ships come in, turn around, and dock in the dock of or in the port of Palm Beach. You can see the black arrows are pointing to some flashing markers. The one on the right is a flashing green, 16 feet tall, number 11. The one on the top left is flashing 6 seconds, 10 feet tall, number 10 in quotes. So it's number 10, even number. That's got to be a red. And then the black arrow at the bottom around the 7 o'clock position is pointing to another flashing red, number 12, also in quotes. You can look at the yellow arrows as you're going out. So if you keep in mind red right rising, in this case if we're going out to sea, then the reds will be on our left, the greens will be on our right. Keep in mind, red right rising, it always works. If they're descending in numbers 12, 10, 8, 6, then they should be on the left or the port side of the boat. A little bit more to the right, these odd brown circles, you can see that we've got the intracoastal waterway, again confirming that is the ICW, and also for you to look out the window, they will have the yellow decals proving it is the intracoastal waterway. And then the vertical odd brown circle is statute mile 1020. So a few minutes ago we were at statute mile 1015. Now we're at statute mile 1020, so we've gone 5 miles in this distance, and again this is 1,020 miles south of Norfolk or Portsmouth, Virginia. Wanted to point out and remind you the north arrow at the top. So mostly maps and charts, north is at the top of the page, but in the MapTech chart kit system, they twist and turn the charts to get as much valuable information on a sheet of paper as possible. In this case, the north is to the left, not at the top of the chart, as is standard. So the north is to the left, we're headed to the right, we're headed south. Wanted to point out this ship channel buoy. It's a flashing green, 2.5 seconds. See the G7. G is green, 7 is the number of the ATON, and that's on the channel or the south side of the channel going out to the ocean. So if we were headed out to the ocean, red right rising, in this case they're descending, the reds would be on our left or our port, and the greens would then be on our right, headed out to sea. We just looked at green 7. Now we're looking out into the ocean itself. We're looking at green number 3, flashing green 4 seconds. So more tools that you'll want to have aboard the boat. Binoculars. Not just one pair of binoculars, but a good pair of binoculars for each crew member, so you don't have to borrow and change the settings. This is a different inlet. This is in the Fort Pierce inlet. We talked about that earlier. And this is a GPS screen showing the red and green buoys at the bottom in that circle. And you can see the red is number 12. You know that by now. Red, even number triangle, 12 is red. That triangular black spot is the icon of the boat that we're on, and we're headed towards the top of the screen. If you look at the top of the screen in the left-hand corner, you can see the north arrow. So this GPS chart plotter screen is set in the heads up direction. So we're heading up. We're not going north, we're heading up. And then that north arrow is reminding us that the north is over to our starboard side around 4 o'clock to our boat's position. Want to point out that yellow arrow, CG stay, that's the Coast Guard station. On electronic charts, they may not have enough space to put full definitions, so they abbreviate as much as possible, and this is the Coast Guard station. Now we're looking at a paper chart. First thing I want you to recognize is everything is upside down. The reason it's upside down is we took the paper chart, spun it around, and oriented it in the direction of travel for our boat. Our boat, of course, there's no icon on the paper chart, so our boat is at the tip of the yellow arrow, and we're headed up the page, and you can see in front of us a green can number 11, that's on the left-hand side of the channel, and a red nun number 10. Keep in mind the ATON, aid to navigation numbers, are in the quotes. So we've got a 10 and 11 in front of us, and we've got the other buoys that are behind us, behind the yellow arrow. As we noticed on the GPS chart plotter, the Coast Guard stay, or the Coast Guard station, you can see that there shown on the paper chart. So we're in the right place, going in the right direction. Here's a little bit more tricky thing to look at. This is a traditional CRT, cathode ray tube radar. So looking at the arrow, our boat is in the center of the screen at the tip of the arrow, and we're looking ahead, and you can see all of these rings, and you can see those two blobs up ahead. Let's check it out and see what's going on here. First of all, this is the Coast Guard station on our left. Remember, we looked at it on the paper chart, we saw it on the GPS chart plotter. This is what it looks like on a radar screen. Looking at the top left, you can see these two numbers, 0.5 nautical miles and 0.1 nautical miles. That's the setting that this radar screen is set to. And looking at the arrow to the left, that is the 0.5 nautical mile ring. So the tip of that arrow is a half of a mile from our boat. Now we've moved the arrow, and you can look at the rings. We're at 0.1, 0.2 nautical miles from the center of the radar, where our boat is. Look inside the white circle, and you can see we've got a big blob at the tip of the yellow arrow, and then we've got two rectangular blobs out near the 0.3 nautical mile ring. The two rectangular blobs are the buoys. They're radar reflecting buoys. But that larger blob has to be a boat. It's not on the electronic chart, it's not on the paper chart, but we see it on the radar. So now we know that we have a boat in front of us. We just have to be curious, is the boat going the same direction we're going, or is it coming at us? So we need to watch the range rings, see if it comes inside the 0.2 ring, closer to the 0.1 ring where we are. So we'll keep an eye on that. And this is what it looks like in the real world. If it's foggy outside, let's say you don't want to go out in the fog, but sometimes you don't have the choice, you have to come home in the fog. So this is what it looks like on foggy days. Look over to screen left, you can see the little bit of a shoreline on screen left. And down screen left, you can see the chart plotter. And remember, we talk about reading the colors. You don't need to study the numbers for the water depth, but you can look at the brown mustard for land, look at the blue for shallow water, and the white for deeper water. So at a glance, you can see all of that information. Now here is a day marker, and I call it a day marker because there's no light. If there were light, it would be called a day beacon, but it's a day marker. And as we said earlier, this is square. So if it's square, think of song, S-O-N-G, square, odd number green. I don't know if you can tell that's a green color due to the poor visibility, but it's square, so we know it's a song, S-O-N-G. Just can't tell what number it is, and that's why those binoculars are so important, so you can reach out and read the number. This is a boat fully accessorized. They are fortunate to have enough dashboard screen area where they've got two 12-inch GPS chart plotters built into the dashboard. The one on the right is called Pure Radar. We say Pure Radar because it's not showing any charting information, only radar information. The one on the left, to port, is showing charting information, and you can see the brown land features, and then you can see the blue shallow water features, and then you may see that purplish overtone. That's actually called an overlay or a radar overlay. So the radar is actually giving us images on both screens. The right-hand screen, pure radar. The left-hand screen has the GPS chart with the radar overlay. And yes, they're set on two different scales. The one on the right is on a longer distance scale. The one on the left is on a closer in scale. So if you're fortunate that you can get a GPS chart plotter radar, you can actually overlay the radar image on top of the chart. Sometimes that's helpful. Sometimes people prefer pure radar, and you can do a split screen. In this case, we're doing two different screens instead of a split screen. Now we get into some exciting things. You may have heard about AIS, Automatic Identification System. This is an AIS overlay on top of a chart. You can see all of the water depths, 744, 900, 768, 372. So you can imagine this is out in the ocean in some very deep water. We are the red icon in the center of the screen. So that's our boat, and we're headed to the top right. Can you see our course line drawn on the chart? We're headed to the top right. And also, what appears to be on a collision course is another icon headed our direction named the Hyundai Integral. So that is a boat or a ship or a tugboat that's transmitting their AIS information that is appearing on our integrated GPS chart plotter, so we can see that vessel and we know his name. So if we need to, we can talk to him on the radio and we can call him by name. So how far away is that boat? The images on the right hand side of the screen are not really that detailed for us, but it will show his latitude, longitude, his direction, and his speed. So let's find out what kind of boat that is. Wow, that's a pretty big boat, or a ship. So that's about 1,000-foot long container ship headed southerly along the Atlantic coast. And of course, I'm using a zoom lens. He's very far away, about a mile's distance. So he's not a problem for us because it's daylight and we can see him. If it were night, it may be a little bit more uncomfortable, but we'd have to believe our instrumentation and know that he's 1 mile away. If you have any concerns, you know his name, you can call him on the radio and talk to him. Now here's a pet peeve that I've got. Look at all of these AIS icons. All of these are boats that are transmitting their AIS signals. Let's explain this view, this chart for a moment. Remember, your GPS chart plotter will rotate the screen around to your direction of travel. So our boat is in the bottom right of the screen, and we're actually traveling south. So north is at the bottom of the screen. So we're traveling south. You can see those 3 different bridges crossing over the waterway. And those are the Stuart, Florida bridges, the Roosevelt Bridge, the Railroad Bridge, and then the larger one is 65 feet and that is the US Highway 1 bridge. But my pet peeve are all of these boats that are tied up at the dock, not moving, not at anchor, and they're transmitting their AIS signals, and they're clogging up the screen. So you've got one choice. If you need to see navigational information that those icons are hiding, you have to turn your AIS off so that you're no longer receiving that signal, and then you can see the navigation aids, ATONs, and then when you're through that very tight area, then you can turn your AIS back on. Just something I wanted to share with you. I think that this is obscuring navigational information that you might need to see to go through those bridges in that more narrow waterway. So let's talk about navigation considerations. We've talked about ideal things with buoys, charts, ATONs, deep water, shallow water, but we need to look at things like tide, current, and wind. That's all important for making your trip safer and more enjoyable. So the tide. A lot of Middle America boaters hear the word tide, but they don't actually know what a tide is. They can read about it, they can assume what it is, but they haven't experienced it. Looking at this screen, we can see the peaks and the valleys. So you can understand that the peak, the highest part, is the high tide mark, and the valley, the lowest part, is the low tide. So we've got text at the bottom. Low tide is at 5:50 a.m. and you can see it's a 0.2 less than normal. That's less than what's shown on your chart. High tide is 11:26. Look at that blue peak in the middle of the screen. It's near 12 o'clock. So again, I'm a visual guy, so I'm seeing it's close to 12. I'm happy. And in this area, the tide is about 1.2 feet above charted low water marks on your chart. Now look at the last low in the screen at 6:12 p.m. and it's 0.6 lower than average. So this is why you need to do your trip planning along with the tides, and if you're going to go through any choke points that have very shallow areas. So you want to plan your trip accordingly with a middle tide or a rising tide, and hopefully you don't kiss the bottom. Now we're looking at this 8 alpha buoy. We already know that's an additional buoy, and you can see the sandbar. We can see it at low tide right now, but at high tide you may not see it. So thank goodness they put in that additional buoy. You can see the regular channel as designed goes to that red piling over to the far left, that red day marker. But thank goodness the Coast Guard put this extra buoy in. You may not see that sandbar in the fog, in the rain, or at night, or even at high tide. So it's low tide, we see the sandbar. Hallelujah. So now we're talking about currents. Currents are river currents, which generally flow down to the Gulf of Mexico or down to the ocean. But some other rivers are bidirectional, where the tides make the river run backwards. Some rivers that run backwards would be the St. Johns River in northern Florida or the Hudson River in New York City. So you can see the current, you can see the waves or the ripples at the bottom left of this buoy. So you want to know about the tidal current or the river current so you can plan your trip taking into account the extra speed of your boat if the current's pushing you, or the slower speed of the boat if the current is slowing down your forward progress. So let's look at these two markers inside of the white circle with the two arrows. These are range markers. On the left you can see Q 20 feet tall, quick green 20 feet tall. That's a flashing green light. And on the right hand side, and we're looking at a paper chart by the way, so everything's upside down. We're looking at the right hand, and it's an ISO phase green, 6 seconds on, 6 seconds off, and that's 32 feet tall. So this is a range marker, and the purpose of the range marker is to help you keep your boat on range when you have currents that are pushing you side to side. This is an up-close photo of a range marker. This is the red and white vertical stripes. Sometimes there will be black and white vertical stripes, and you have to read on the chart RW, red, white, BW, black, white, and then you can see these 4 solar panels, the battery to the left, and the bright light. So this is what you'll see when you're up close and personal, and this is what you'll see from your boat. Can you see the 2 red and white vertical striped range markers? The one nearer to us is short. I think it was 20 feet tall. And the one in the back is higher. I think that was 35 feet tall. So you can see them in the daytime, and at night they will have the flashing lights. By the way, this is Fort Pierce Inlet, and that's called the Redneck Riviera on the left-hand shore, or the northern shore of the inlet. Now you can see that we're almost perfectly lined up. I don't know if you can appreciate the little wave action and the turbulence in the water, but you can see if you're a big boat, maybe a tugboat, maybe a mega yacht, or maybe this current's running at 2 miles per hour and it's dragging the boat over to the side, the range markers are definitely helpful. By the way, can you tell if the tide's coming in or going out? I can tell by looking at the boats anchored on the left screen. So they're pointing into the current. That means the current is going out to the ocean. An easy tattletale, easy for you to see. Now we're up in the Chesapeake Bay. This is near Baltimore, and these are range markers. They don't have the RW boards or the black and white boards, but they've got extremely bright lights. And of course, in the Chesapeake Bay, which is pretty big and pretty deep, this is aimed at ships more than it is for boats our size in the 40, 50, 60 foot neighborhood. But here you can see that we're off range. Now we're perfectly in alignment and we're on range. So this is the way the range markers work with the lights, daytime or nighttime. And then you saw the red and white boards or the black and white boards, and that's also what you would use in the daytime. Lights at night, bad weather, the boards in the daytime. Talk about wind. Wind can affect the boat. You can see the wave action and figure which way the wind is coming from, but we're also concerned about docking the boat or maybe even anchoring the boat. So if you're going to go into a marina and they give you a slip assignment, you need to know if there's a current running through the marina, and you need to know what the wind is doing so that you can compensate for the current or for the wind. If you've got a flagstaff on the bow of your boat, you can fly a burgee. This is the America's Great Loop Cruising Association burgee. So you can see that the wind is from my starboard blowing to my port. Very helpful to know when you're going into a marina and docking the boat. So let's review this chart. We don't have any arrows or circles to give you clues what we're talking about. So let's start at the center top of the screen. You can see the north arrow because these charts are not always north at the top of the page. In this case, north is to the left-hand side of the page. On the left-hand side of the page, you see Singer Island. You'll come down the left-hand side. You can see where we've drawn with a yellow highlighter the intracoastal waterway around Peanut Island near the port of Palm Beach. By the way, Peanut Island is where President John F. Kennedy had his bomb shelter during the Cuban Missile Crisis, and his winter White House was on Palm Beach Island. Little fun fact right there. But at a glance, you can see the land, you can see the blue shallow water, and you can see the white deeper water. So these are things that we want you to look at a glance, get an idea of what's going on, maybe grab a magnifying glass so you can study it a little bit better. But I hope this has given you some ideas of how you can operate your boat, take a look at the chart, take a look out the window, and see the best course of action. Thank you for joining us, Navigation Made Easy. I'd like to share with you some other videos that we've got available, training videos. We do streaming on Vimeo. Hopefully you've already been there. But we've got locking, docking, anchoring, how to select the perfect boat for you, and drawbridges. We also have training deliveries that we've done with new boat owners going up and down the East Coast and the Gulf Coast. And last thing I'd like to bring your attention to is our What to Expect of a Marine Survey. This is a 44-page primer to help you get ready for the survey when you are buying your first boat. And we also offer consulting. So if you have questions, you know who to call. Ask Captain Chris.